Hello everyone and welcome to the complete Terraform course 2026. I'm Sureka and I will be your instructor throughout this journey. If you have ever wanted to automate Azure deployments, eliminate repetitive manual work, or build real world cloud infrastructure using code, then you are in the right place. In this course, we will start from absolute basics. So, even if you are never used Terraform before, don't worry. I will guide you step by step through every concept with live demonstrations, hands on labs, and real Azure projects. By the end of this course, you will be able to confidently write Terraform code, deploy Azure infrastructure, build reusable modules, integrate Terraform with GitHub and CI/CD pipelines, and understand how Terraform is used in real enterprise environments. Whether you are preparing for a cloud engineering role, moving into DevOps, becoming an Azure Architect, or simply upgrading your Azure skills, this course is designed to give you practical knowledge that you can immediately apply in your career. So let's begin our Terraform journey and start building cloud infrastructure the modern way with code. Welcome to the course and let's get started. Terraform versus ARM templates versus Bicep. In this video, we will compare three important infrastructure as code technologies: Terraform, ARM templates, Bicep. We will understand what is infrastructure as code, how Terraform works, how ARM templates work, what makes Bicep different, which tool is best for your Azure career in 2026. By the end of this video, you will know which technology you should focus on learning. Imagine your manager just handed you a ticket. You need to provision a full Azure environment from scratch by end of the day, like 50 virtual missions, 10 virtual networks, and storage accounts. Now the question is, would you manually open the Azure portal hundreds of times, click through every wizard, copy the same configuration again and again, or would you automate the entire deployment with a single command? In the traditional approach, like manual Azure portal deployment, let's imagine doing this manually for every virtual mission. You need to select the subscription, choose the resource group. See here, if we'll open Azure portal, you have to open virtual missions, and you have to click on select virtual mission, and you have to select virtual mission. You have to create a resource group, and you have to select a virtual mission name and availability options, and then you have to select disks, and then you have to select networks, and you have to create virtual network, and you have to create public IP, and you have to select the ports, and then you have to go to management, and you have to select based on your requirement and monitoring, and like this you have to select 50 times. You have to click like this if you want to create 50 virtual missions. Here the problem with manual deployment, here it takes time consumption. A task that should take hours can take days. Human errors, one wrong setting can create like security issues, configuration differences, connectivity problems. Imagine you are creating first VM with some name and you are giving VNet, and in the 10th VM, like you cannot provide the same configuration because you may not able to remember that. You may give different configuration settings. So here there is a chance of human errors, and there will be a connectivity problems and configuration differences. And then the third thing is lack of consistency. Imagine your first VM has correct security rules, correct tags, correct monitoring setting, but your 25th VM is missing something important. Manual process make consistency difficult. And the fourth one is difficult recovery. What happens if you need the same environment again? For example, disaster recovery or testing environment or development environment. You would have to repeat everything manually, like 50 times you have to create 50 VMs. But that will not be the same configuration you can create. There is no guarantee, right? There should be a human errors, and there is a lack of consistency, configuration differences, and connectivity problems also will come. So it will be a difficult to create manually. So here, like infrastructure as a code is the solution for this. This is where like infrastructure as code changes everything. Instead of manually creating resources, you define the desired infrastructure in code. For example, if you'll open Terraform, and you can define the resources, and you can save this code, and you can use the same code and you can deploy in the testing environment or development environment or in disaster recovery environment. You can deploy the same code. So here the main advantage is there is no manual errors, and there is no configuration differences, and there is no like lack of consistency. So you can use the same code, and also you can do within 1 hour. You can do everything. Here, why companies use Terraform? Terraform provides automation, repeatable deployments, version controlled infrastructure, faster provisioning, consistent environments, reduced human errors. This is why Terraform is widely used by cloud engineers, DevOps engineers, Azure Architects, platform engineering teams. In today's video, like we are going to build a strong foundation by understanding the 3 major infrastructure as code tools used by Azure engineers: ARM templates, Azure Bicep, Terraform. By the end of this video, you will have a clear and practical understanding of what infrastructure as code means, how these 3 technologies work, where each tool fits in real world Azure environments, which tool you should learn first based on your career goals. This comparison is important because choosing the right infrastructure as code tool can directly impact your growth as an Azure Administrator, Cloud Engineer, DevOps Engineer, Azure Solutions Architect. What infrastructure as code? Infrastructure as code, or IAC, is the practice of managing and provisioning infrastructure using code instead of manually creating resources through a cloud portal. Traditionally, administrators would open Azure portal, click through deployment screens, configure settings manually, repeat the same process for every environment. This approach works for smaller environments, but it becomes challenging at enterprise scale. Earlier we saw the example, right? 50 virtual machines, multiple virtual networks, multiple storage accounts, security rules, monitoring configuration. Doing everything manually creates more chances for mistakes, inconsistent configurations, longer deployment times. With IAC, infrastructure as code, we define our desired infrastructure in configuration files. The process becomes like write code and then review the changes, deploy automatically. Azure creates resources. So here, faster deployments and repeatable environments, version controlled infrastructure, reduced human errors, better collaboration between teams. This is the foundation of modern cloud engineering. Next is ARM templates. The first Azure infrastructure as a code technology we will discuss is Azure Resource Manager templates. ARM templates are Microsoft's original native infrastructure as code solution for Azure. ARM templates use JSON format, Azure Resource Manager deployment engine, declarative infrastructure defines. With ARM templates, you can deploy virtual machines, storage accounts, virtual networks, app services, databases, security configurations. Here, like instead of manually creating a storage account, you define storage account name, location, performance setting, replication type inside a JSON template. Azure Resource Manager reads the template and creates the resource. Advantages of ARM templates: provide deep Azure integration, native Microsoft support, complete Azure resource coverage, enterprise deployment capability. Here the challenges are, however, ARM templates also have limitations because they use JSON. Files can become very large and syntax can become complex. Templates are harder to read and maintain. This led Microsoft to introduce a simpler option, that is Azure Bicep. Bicep is Microsoft's modern infrastructure as code language designed specifically for Azure. It is a simpler and cleaner way to write ARM templates. Bicep provides easier syntax, better readability, improved developer experience, Azure native deployment. Why was Bicep created? Microsoft recognized that ARM templates were powerful but sometimes difficult to manage. Bicep solves this by providing a cleaner language that compiles into ARM templates. They deploy through Azure Resource Manager. So Bicep does not replace Azure Resource Manager. It improves the developer experience. For example, instead of writing complex JSON, you can write simpler Bicep file. For example, here you can see the example Bicep code. Here the syntax is easier for engineers to understand and maintain. Terraform. Now let's talk about Terraform. Terraform is an open source infrastructure as code tool created by HashiCorp. Terraform uses HCL, HashiCorp configuration language. Terraform allows engineers to manage infrastructure across multiple platforms. For example, Microsoft Azure, AWS, Google Cloud, Kubernetes, VMware. These all can use Terraform. Why Terraform become popular? Terraform introduced several powerful concepts. Multi-cloud support. Organizations can use one tool across different cloud providers. Infrastructure state management. Terraform tracks the current state of your infrastructure. This helps understand what exists, what changed, what needs updating. And teams can create reusable infrastructure components. For example, network module can create VNets, subnets, NSGs, routes, then reuse it across multiple environments. Which tool to learn first? The answer depends on your career goal. If you are an Azure Administrator, starts with Azure Bicep. Why? Because it is Azure native, it is easier to learn, it aligns with Azure Resource Manager. It helps you understand Azure deployments. If you want a DevOps or cloud engineer career, start with Terraform. Why? Because Terraform is widely used for enterprise automation, CI/CD pipelines, platform engineering, multi-cloud deployments. If you want to become an Azure architect, learn Terraform and Bicep because architects need to understand Azure native solutions, enterprise automation patterns, infrastructure design, deployment strategies. So here the recommended learning path for 2026 for Azure professionals. My recommended order is step 1, understand infrastructure as code concepts. Next, learn Azure Bicep fundamentals, then master Terraform. And then use Terraform with DevOps pipelines. And then build enterprise infrastructure projects. Today, we learn what infrastructure as code means, ARM templates, Azure Bicep, Terraform. Which tool to learn first based on your career goals? Requires several configuration sections in an ARM template. Here is a minimal ARM template example. Understanding the template structure, let's break down the important sections. First section defines schema. This tells Azure what template format and structure we are using. Then content version. This defines the version of the template. It helps teams track template changes over time. The main part here is resource section. This section defines the Azure resources we want to deploy. Microsoft storage accounts, which represents an Azure storage account. Next, resource type. This is the type Microsoft storage accounts. This tells Azure, what resource we are deploying. Every Azure resource has its own resource type. For example, virtual mission, Microsoft Compute virtual missions. See here, type, we can see Microsoft storage accounts. But for virtual missions, it could be Microsoft Compute virtual missions, because it is a part of compute resources. So it is a compute. See here it gave error because it is not part of storage, right? It is part of virtual mission. So, and if you want to create a virtual networks, then you have to change the type into virtual networks. So here if you want to create storage accounts, you can change the type into storage accounts. And then API version. Azure resources are managed through APIs. The API version defines which resource capabilities and properties are available. And then name and location. Name, you can provide the name whichever you want to create. It is a name of the storage account. And the location. Location, based on the location where you want to create, you can provide that location details. And then deploy the storage account in the same region as the resource group. Like wherever you have the resource group deployed, like for example resource group deployed in East US, you have to select East US. And then you have to provide the SKU name. It defines the storage redundancy option. Like it is a local zone redundance or region redundant. You can mention the LRS, GRS or ZRS. Based on that you can provide the name. So here in this example, standard performance locally redundant storage, because this is the LRS. Kind storage V2, it defines the storage account type. Storage V2 is the modern general purpose storage account type in Azure. Why this becomes challenging? Now remember, this example is only creating one simple storage account. In a real enterprise environment, you need to deploy virtual missions, virtual networks, subnets, network security groups, load balancers, private endpoints, role assignments, monitoring configuration. Each resource adds more JSON. Like these columns will be more difficult while you are adding more resources. So here a production ARM template can grow into hundreds of resources, thousands of lines of JSON, complex dependencies, multiple parameters, nested templates. At that point, teams may face challenges. This challenge led Microsoft to introduce Azure Bicep. It is a simpler language that uses clearer syntax, is easier to read. Still, deployments through Azure Resource Manager, and many organizations also adopted Terraform, that is also multi-cloud capability. So let's see the example of Bicep. you can see the difference. Bicep file, it takes only 8 lines, but here it took like 16 lines. Here you are mentioning only the resource storage account type, and then you are giving the storage account name, location, and SKU and kind like what is the type of storage account. But here you no need to provide API version and schema, content version. These all no need to give. Only it is a straightforward. Only whatever you want to create, you will provide that information. So this is the main difference of Azure ARM and Azure like Bicep. Here Bicep is not the replacement of ARM template. Once you apply you write the code and you apply the deployment, this Bicep file will convert into ARM template and then it will deploy the resources. ఉండి ఇది స్టాప్ చేసేస్తా, అందుకైతే మళ్ళీ జాయిన్ చేస్తా.